So we're moving on today to solving systems of three equations. Now, remember back in 8th grade, we had systems of two equations. So there are two equations here, and if we have two equations, that means we have two variables to solve for. Remember, you can add any equations together, you can subtract, multiply, or divide any equations. As long as you do what you do to one side, you do to the other. The object is to manipulate these equations so that they reduce to get rid of one or more of the variables. So just to remember from 8th grade, if we looked at this system of equations here, we would probably multiply this bottom equation by a -4. It would give us -4x plus 8y equals 4. Now, why would we do that? Because the top equation is 4x plus 3y equals 7. So see here, we did the multiply any equation. We multiplied 1. Now we're going to add the equations together. And when we do that, the x's cancel out, leaving us with one variable. It's very easy to solve for y. Then we can just plug this back in and we can figure out what x is. Well, now we're doing the same thing, but we've got three equations. And when we have three equations, we have three variables. So let's just dig right into this. The first thing I notice is that one z is positive and the other z is negative. This is in equations 2 and 3. So my first step is going to be to isolate these two, and I'm going to add these equations together. When I add them together, I get 5x plus 3y. The z's cancel out, equal 11. So now I have decided that I want to make equations with just the variables x and y in it, because if I can get them down to two equations of two variables, then I can continue to solve them like we did here in 8th grade. All right, so how else can I get an x and a y and a z out of there? Well, I'm going back to the original equations, and I notice that the first equation and the third equation also have a z and a -z, and if I added those two together, I'd be able to cancel out the z. So 2x and x gets me 3x. 3y and 4y gets me 7y. The z's cancel out, and I get 17. Now I'm back to 8th grade, and I am going to, I'm going to multiply this top equation by 3 and this bottom equation by -5. Rewriting. And then on the bottom, I can now add them together. Let's see, 35 minus 9 is -26. And that would be 252 negative. So I just figured out one of my variables. My y equals 2. Well, all right, if y equals 2, I can, like we did on the front page, I can plug that back into one of these to figure out what x is, and it doesn't matter which one. You could have even put this back into one of the equations up here, but it wouldn't have helped us. So I'm going to go over here and I'm going to choose the 5x plus 3 times 2 gets me 11. 5x plus 6 gets me 11. 5x gets me 5. X equals 1. So now I know x is 1, y is 2, and now I have to go back to one of my original equations and put in my x and my y. It doesn't matter which one looks the easiest. To tell you the truth, number 3 here looks the easiest. So I have x is 1, 4y, so 4, and I think y is 2, plus that last letter I'm looking for, z, should get me 12. So that's 8, 9 plus z gets me 12. So it's looking like z is 3. All right, so I'm going to check all this. So let me come back up here. I'm going to grab the original equations. Put them down here. I'm going to check everything. All right. 2 times, well, I think x is 1, plus 3 times, well, I think y is 2, minus 3, does that get me 5? 2 plus 6 is 8. 8 minus 3 is 5. Okay, that checks. 4, my x value is 1, minus my y value is 2, minus my z value of 3, better get me negative 1. 4 minus 2 is 2. 2 minus 3 is negative 1. Looking good. One more to go. X is 1 plus 4 times the y value, which is 2, plus 3, better get me 12. 1 plus 8 is 9. 9 plus 3 is 12. Yep, so my answers of x is 1, y is 2, and z is 3, all checked. So you can see this can get very long, and you have to search. All right, example 2. Got 3 equations here, and instead of x, y, and z, I have r, s, and u, but I like something here. This makes me smile right here. There's already only 2 variables right there. Now watch. It also helps if you write down your steps, so when you go back later, you can follow them. So, whoops, got to change that back to a regular pen. So I think I'm going to add number 2 and number 3. That's my shortcut instead of saying equation 2 and equation 3. So I'm going to come over here. I'm going to say s plus u equals 4, and I'm going to add r minus s minus u equals 2. Can you see why I chose those? Because life is really good when I add them together. The s's and the u's cancel out, and right away I know that the r is 6. So I'm going to come over here and write that down. Now, let's see, what else can I do? Now that I know r is 6, I can substitute r equals 6 into, well, I'm going to substitute it into equation 1. When I do that, I get 6 plus 2s minus u equals 8. 2s minus u equals 2. Well, I just created an equation that only has 2 variables. So step 3 is now going to be use equations number 2 and new equation, that would be that one right there. So I'm going to take the 2s minus u equals 2. I'm going to take equation 2, which is s plus u equals 4. I'm going to add them together, and I get 3s equals 6, so s equals 2. All right, all I have to do is find u, and well, that's not hard, because I know right here that equation, I'm going to use equation 2 again, s plus u has to equal 4. And I know s is 2, so 2 plus u equals 4, so that means u has to be 2. And trust me, if I go back and check them, well, I can. 2 plus 2 equals 4, all right? This one said take r, which is 6, minus 2, and I should get 2, and yes, I do. This one says 6 plus 2 times 2 minus 2. 6 plus 4 minus 2 is 8. It all checks. Now, you may be saying, like, I wouldn't see all this stuff. It takes practice. We are going to take 2 days to do this topic. Okay, here's our last one for this video. This one looks really complex. Lots of coefficients, lots of big numbers. So the first thing I'm going to look for is I'm looking at my x's, I'm looking at my y's, I'm looking at my z's, and right now I see some nice stuff. I see that if I add these two equations together, my y's could cancel out. Or if I add the first and second equations together, my z's could cancel out. It doesn't matter where you start. Let's start with that. So I'm going to take equation 1 and equation 2. I'm going to add them together. All right, so when I add them together, the z's cancel out, and I have 11x plus 4y equals, what is that? When I 42 minus 14, 28. Just checking myself here. 12. Yes, 28. All right, so that means I'm looking to form another equation that has only x's and only y's in it. All right, so that means I could take equations 2 and equation 3 and manipulate them. So equation 2 is 7x minus y plus 2z equals 42, and 3x plus y plus 4z equals 28. Now, I don't want to just add these together, because if I cross the y's out, that'll leave me with x's and z's. I'd have to be left with x's and y's. So that means I want to get rid of these z's. So I'm going to multiply this first equation by negative 2. When I do that, I get negative 14x plus 2y minus 4z equals negative 84. And then I still have my equation below, 3x plus y plus 4z equals 28. When I add those together, I get negative 11x plus 3y, the z's cancel out, equal, let's see, 84 minus 28, that's 56 negative. All right, so my new equations now, and I didn't even plan this. I just took a wild stab in the dark, and look at the beauty that happened. If I take this equation and I take my new equation over here, I have beauty happen. when I add those together, my x's cancel out, and I've got 7y equals negative 28. So y equals a negative 4. Awesome! I'm just going to write that up here so I don't lose it. Y equals negative 4. Well, now I am going to just go back down to here. And I'm just going to plug y equals negative 4 back into this equation to help me find x. So plug into equations. So 11x plus 4 times negative 4 equals 28. 11x minus 16 equals 28. Move the 16 over. So that is 14, 44. X now equals 4. Great. Come back up here. Now I know x equals 4, and I've got 2 out of 3. So all I have to do now is pick my easiest equation that I have left here and put in x equals 4 and y equals negative 4. And that to me looks like equation 2. So 7x minus y plus 2x. So 7x minus y plus 2z, equals 42. 7, I found x to be 4, minus y, which is a negative 4, plus 2 times z, which I'm looking for, should get me 42. 28 plus 4 plus 2z equals 42. So that ends up being 32 plus 2z equals 42. I think we can see this. 2z equals 10. Z equals 5. So I can check these, and they do check. Save the time. And we will be solving systems of 3 equations for the next 2 days.